Hello everyone, today we're going to look at full hypothesis test examples. When we calculate the p-value, we have three types to consider, and they depend on what the alternative hypothesis is. So it doesn't really matter the type of null hypothesis, it matters what the alternative hypothesis is. So let's suppose that x bar is m. One of the types of alternative hypotheses is that mu is less than some number. So we're going to say mu is less than n. And if that's my alternative hypothesis, then my p-value is the probability that x, remember that this is really x bar because it's the average of a sample, is less than m. So we're using less than, we're using less than. The other type is greater than. If the alternative hypothesis is mu is greater than n, then the p-value is the probability that x is greater than m. So again, greater than, greater than. And then the last one is not equal to. So if mu is not equal to n is my alternative hypothesis, then p is twice the probability that x is less than m, or twice the probability that x is greater than m, depending on how m and n are related. Okay, so whichever one makes the most sense. Pictorially, they look like the following. So mu is less than n is this guy. Mu greater than m is the middle one. And then, again, if we're not equal to, what we're really doing is we're doubling the two tails. So if mu is not equal to n is the alternative hypothesis, then we're doubling one tail. Okay, so again, these are our possibilities. So we really have to pay attention to what our alternative hypothesis is, because that's going to determine what we do for p. Also remember that if we do not know sigma, we must use the student t distribution. So just like with the confidence intervals, if we don't know sigma, if we have to use s, the sample standard deviation, we have to use the student t distribution and not the normal distribution. If we are using the student t distribution, we need to find what's called the test statistic. So the test statistic is t, and it is x minus x bar divided by s over the square root of n. And this is basically the standardizing for the t distribution. If you replace s with sigma, then this is exactly the standardizing for the normal curve. But because it's s, not sigma, it's the t distribution standardizing version. So let's try this with an example. Flour is packed in 3-pound bags. An inspector suspects the bags may be overfilled. Okay, so right there, the inspector suspects the bags may be overfilled is telling us that the claim is that mu is greater than 3. So if we're claiming that mu is greater than 3, there's no equal sign in that, which means the alternative hypothesis must be that mu is greater than 3. And then we keep reading. A sample of 80 bags produces a mean of 3.21 pounds and a standard deviation of 0.96 pounds. Is there enough evidence to conclude that the inspector is correct at alpha equaling 0.025? So the first thing we want to do is write down the null and alternative hypotheses. So we just talked about the alternative hypothesis. It must be that mu is bigger than 3. And for the null hypothesis, we're going to do the true contradiction less than or equal to 3. And again, make sure that you always know which one is the claim, because we're going to need that later. Next, we're going to list the values we need. So x bar is 3.21, n is 80, and then we're given the sample standard deviation of 0.96, which means we need to use the student t distribution, which means we need the degrees of freedom. And remember that df is n minus 1, so if n is 80, df must be 79, and then alpha is 0.025. The next step is to find the test statistic if needed, which in this case it is because we're using the student t distribution, and then we'll find the p-value. So the t-value, the test statistic, is again x minus x bar divided by s over the square root of n. So we'll plug in our numbers. Make sure that if you're plugging this into Excel or your calculator all at once, that you're putting your denominator in parentheses, because you need to do the smaller division. You need to do this division before the other one. So you're going against order of operations. So you need parentheses around the bottom. You should be getting 1.957. Because our alternative hypothesis is greater than, that is what's going to be our p-value. Our p-value is going to be the probability that t is greater than 1.957. We need to use Excel to find this. So again, if you haven't already, I want you to pause this and open up Excel and type these in according to the commands that we talked about in class to make sure that you're getting the same numbers. Okay. So if I put this into Excel, I should get 0.02694. So that is my p-value. The next step is deciding whether we reject or fail to reject the null hypothesis. So remember, we're comparing our p-value to alpha. Our p-value is bigger than alpha, not by much, but it is bigger. So we fail to reject the null hypothesis. We say p is too big to say that it must not have actually been true. So it's not a rare enough probability. The last step is to, again, reword this into the claim. So if we fail to reject the null hypothesis, what does that mean for our claim that the inspector thinks the bags are overfilled? Well, if we fail to reject the null hypothesis, then that's the same as saying that we cannot say that the bags are overfilled. So that X bar that we had could just be a coincidence, because it's not always going to be exactly 3. Okay. So again, it's really important that you can translate your part D to part E. If I fail to reject or reject the null hypothesis, what does that mean to the actual question being asked? So again, in our case, we say that we cannot say that the bags are overfilled. We're not saying that they're underfilled. We're not saying that they're filled correctly. We just cannot say that they are overfilled. So let's try another one. Statistics students believe the mean test score of their first test is a 75. It is known that sigma is 5.3. Test this claim at the 0.05 significance level if a sample of 30 students had a mean of 72.4. So again, the first thing we always do is rewrite the null and alternative hypotheses. So statistics students believe the mean test score of their first test is a 75. So the claim is that mu equals 75. Because there's an equal sign in that, it must be the null hypothesis. And again, we're going to choose the true contradiction for the alternative, mu is not 75. Because I'm not sure if it's bigger or smaller than 75, so I'm just going to go with not equal to as the opposite. So again, in this case, the claim is the null hypothesis, unlike last time. So list the values we need. X bar is 72.4, N is 30, we're given sigma, it's 5.3, and alpha is 0.05. So since we're given sigma, we can use the normal curve, not the student t-distribution, and I don't have a degrees of freedom. C, find the test statistic if needed and the p-value. So there is no test statistic needed. Again, I'm using the normal curve. And since my alternative hypothesis is not equal to, my p-value is going to be twice the probability that x is less than 72.4 because my x bar is less than my mu. So it's going to be twice the probability, again, that x is less than 72.4. Again, this is something we can do in Excel, so I want you to try it and make sure you get the same answer, which is 0.007. Remember that when you're doing the normal curve, it is part of the central limit theorem. So your sigma is your original sigma divided by the square root of n. So don't forget that part. That's probably the biggest mistake that I see, is they'll just use your original sigma. But it's the central limit theorem, so sigma over the square root of n. Part D, do we reject or fail to reject the null hypothesis? So again, we're comparing alpha to your p-value. In this case, the p-value is smaller than alpha, which means we reject the null hypothesis. We say there's no way that this actually occurred just in the normal scheme of things. So we cannot say the null hypothesis is true. And then what does that mean in terms of our actual question? So we're rejecting the null hypothesis. The null hypothesis was the claim, so we're rejecting the claim. The mean test score is not 75. Okay, so let's try another one. It is claimed that the iPhone XR has a battery life of at least 24 hours of talk time on wireless. Test this claim using a 2% significance level if a survey was done on 50 iPhone XRs and we found that X bar was 22.5 hours and S is 5.75 hours. So again, step A is write the null and alternative hypotheses. So we say it's claimed that the iPhone XR has a battery life of at least 24 hours. At least 24 hours is mu is greater than or equal to 24. Again, there's an equal sign in there, so that must be the null hypothesis. The alternative hypothesis, therefore, must be the opposite. Mu is less than 24. And then we list the values we need. So X bar is a 22.5, S is the 5.75, N is 50, degrees of freedom is 49 because we're given S, which means we need to use the student t distribution, and alpha is 0.02. Find the test statistic if needed and the p-value. So again, we're doing the student t distribution, so we do need the test statistic. So again, the t is x minus x bar over s divided by root n. So I've plugged in the values here. Again, be careful, make sure you do order of operations correctly. And we should be getting negative 1.845. Okay. For the p-value, we're going to be using the probability that t is less than this number because the alternative hypothesis was mu is less than. So we're going to use that same operation, less than. Again, I'll use Excel for it. I want you to try it out too. Make sure you get the same answer. 0.0355. Next, do we reject or fail to reject the null hypothesis? Alpha is less than p, and alpha was 0.02, so we fail to reject the null hypothesis. Answer the question asked. So we cannot conclude that the claim that the iPhone XR has a battery life of at least 24 hours is false. So remember, we're failing to reject the null hypothesis. The null hypothesis was the claim, so we're failing to reject the claim. We cannot conclude that the claim is false. We're not saying the claim is true, we're just saying we cannot say it's false. So it's kind of like a double negative, but there is a subtle distinction between the two. So you just got to be careful with it. Okay. So let's try one more. Sarah heard that her college's average student IQ was 105. She thinks this is wrong. Is Sarah correct, given the following information on a survey of a sample of her classmates? X bar is 110, sigma is 15, N is 85, alpha is 0.05. So step A, write the null and alternative hypotheses. So Sarah heard that her college's average student IQ is 105. So mu is 105, mu equals 105. That must be the null hypothesis. The alternative hypothesis is not equal to 105 because Sarah thinks this is wrong. So wrong would be not 105. Okay. And again, this is Sarah's claim that the college's claim is wrong. List the values we need for the problem. They were listed right there for us in the problem. And again, notice we know sigma. Sigma is 15. So we can use the normal curve. We don't have to use the student t-distribution. So part C, find the test statistic if needed, it's not, and the p-value. So we only need the p-value. Our alternative hypothesis was not equal to, so our p-value is going to be twice a probability, and it's going to be twice the probability that x is greater than 110 because our x bar is bigger than our mu. So we want twice the probability that x bar is greater than 110. Again, when you're plugging it into Excel, remember that sigma is not 15. It's 15 divided by the square root of n. And we should be getting 0.002. Do we reject or fail to reject the null hypothesis? Alpha is greater than p, so we reject the null hypothesis. Say p is too small to be a coincidence. It cannot be true. So what does this mean in terms of Sarah's claim that the college's claim was wrong? So we reject the null hypothesis, so we're rejecting the equality. So we're saying the average IQ across the college is not 105. Sarah is correct. Okay. So again, sometimes it can be a little confusing, so it's really, really important that you write down which one is the claim, the null hypothesis, the alternative hypothesis. Okay. So if you haven't already, make sure you read through the section and let me know if you have any questions. Thanks.